Welcome to our exploration of adrenal insufficiency. Today we'll unravel the complexities of this condition, including its primary, secondary, and tertiary forms, and the crucial role of the hypothalamic pituitary adrenal or HPA axis. To begin, let's shed some light on the HPA axis. This intricate neuroendocrine system is pivotal in regulating our body's response to stress and maintaining homeostasis. The HPA axis is a trio comprised of the hypothalamus, the pituitary gland, and the adrenal glands. Together, they orchestrate the production and regulation of cortisol, our body's primary stress hormone. Picture this. When the hypothalamus, the command center of the brain, senses stress, it springs into action. It releases a hormone known as corticotropin-releasing hormone, or CRH. This CRH is a signal, a call to action for the pituitary gland. Responding to this call, the pituitary gland releases adrenocorticotropic hormone, or ACH. Now this ACH has a crucial mission. It journeys to the adrenal glands nestled atop our kidneys. Here it stimulates the synthesis and release of cortisol, our body's primary stress hormone. This cortisol then courses through our bloodstream, ready to tackle the stressor at hand. However, this is not a one-way street. The HPA axis is a feedback loop, meaning the levels of cortisol in the blood can signal back to the hypothalamus and pituitary gland to adjust the production of CRH and ACTH, ensuring a balanced response to stress. This dynamic interaction between the hypothalamus, pituitary gland, and adrenal glands is a marvel of biological engineering. It ensures that our bodies can adapt to the ever-changing demands of our environment, maintaining a delicate balance. But what happens when this balance is disrupted? This is where adrenal insufficiency enters the picture, a condition characterized by inadequate cortisol production due to dysfunction at any point along the HPA axis. Thus, the HPA axis is a complex system that plays a vital role in our body's response to stress. Understanding its intricacies is the first step in unraveling the mysteries of adrenal insufficiency. So let's delve deeper into this captivating world in our upcoming segments. Now let's explore primary adrenal insufficiency, also known as Addison's disease, which occurs due to dysfunction of the adrenal glands themselves. This condition is often the result of an autoimmune response where the body's immune system mistakenly targets and destroys the adrenal cortex, the outer layer of the adrenal glands. This is the region responsible for producing cortisol, a hormone vital for regulating the body's response to stress and maintaining normal metabolic functions. When the adrenal glands are damaged, they fail to produce adequate amounts of cortisol, disrupting the delicate balance of the hypothalamic pituitary adrenal or HPA axis. This disruption can manifest in a variety of symptoms, often gradual and non-specific, making the condition difficult to diagnose initially. Common symptoms include chronic fatigue, muscle weakness, loss of appetite, and unexplained weight loss. Individuals may also experience low blood pressure, leading to dizziness or fainting, and a craving for salt due to the loss of sodium through urine. In severe cases, a sudden and sharp decrease in cortisol levels can lead to an adrenal crisis, a life-threatening situation that requires immediate medical attention. But why does cortisol deficiency lead to these symptoms? Well, cortisol plays several key roles in the body. It helps regulate blood sugar levels, helps in food metabolism, assists in controlling our response to stress, and even plays a part in our immune response. When there's not enough of it, these processes can go awry, leading to the symptoms we just discussed. Additionally, in primary adrenal insufficiency, the lack of cortisol feedback triggers an increase in the release of adrenocorticotropic hormone, or ACH, by the pituitary gland. This is the body's attempt to stimulate the adrenal glands to produce more cortisol. However, if the adrenal glands are damaged, they cannot respond to this signal, leading to an overproduction of ACTH and further disrupting the HPA axis. In primary adrenal insufficiency, the adrenal glands fail to produce sufficient cortisol, leading to a variety of symptoms and increased secretion of ACH. We now move on to secondary adrenal insufficiency, which arises from a dysfunction of the pituitary gland, resulting in decreased ACTH production. Secondary adrenal insufficiency is a fascinating condition that provides a window into the intricacies of the hypothalamic pituitary adrenal or HPA axis. This form of adrenal insufficiency is not due to a problem with the adrenal glands themselves, but rather with the pituitary gland, a pea-sized structure located at the base of the brain. The pituitary gland is often referred to as the master gland because it controls many other hormone-secreting glands in the body, including the adrenal glands. In secondary adrenal insufficiency, the pituitary gland fails to produce an adequate amount of ACH, or adrenocorticotropic hormone. This chemical messenger is responsible for stimulating the adrenal glands to produce cortisol, which helps the body respond to stress, maintain blood pressure and cardiovascular function, slow the immune system's inflammatory response, and balance the effects of insulin to maintain blood sugar levels. When the pituitary gland doesn't produce enough ACH, the adrenal glands aren't stimulated to produce cortisol. This results in lower levels of this vital hormone in the bloodstream. Symptoms of secondary adrenal insufficiency can include fatigue, low blood pressure, weight loss, nausea, and difficulty responding to stress. However, an important distinction exists between secondary adrenal insufficiency and the primary form we discussed earlier. In primary adrenal insufficiency, the problem lies with the adrenal glands themselves, and they can't produce cortisol even when ACTH levels are high. But in secondary adrenal insufficiency, the adrenal glands are structurally normal and can still produce cortisol if they receive the right signals. This means that if a person with secondary adrenal insufficiency were to receive an injection of ACTH, their adrenal glands would respond and produce cortisol. This is a key diagnostic test used by endocrinologists to differentiate between primary and secondary adrenal insufficiency. In secondary adrenal insufficiency, decreased ACTH levels lead to reduced cortisol production, but the adrenal glands remain capable of responding to ACTH stimulation. This difference underscores the importance of understanding the HPA axis and the complex interplay between these glands and hormones in maintaining balance within the body. Finally, we examine tertiary adrenal insufficiency, which occurs due to dysfunction of the hypothalamus, leading to decreased corticotropin-releasing hormone, or CRH, production and subsequent reduction in adrenocorticotropic hormone, or ACEH secretion. To understand tertiary adrenal insufficiency, we must first revisit the hypothalamic pituitary adrenal axis, or the HPA axis. As the control center of our stress response, the hypothalamus dictates the release of CRH, which in turn stimulates the pituitary gland to release ACH. This hormone then prompts the adrenal glands to produce cortisol, our body's primary stress hormone. In tertiary adrenal insufficiency, the issue begins in the hypothalamus. For various reasons such as prolonged steroid use or damage to the hypothalamus itself, this gland may fail to produce enough CRH. This failure disrupts the domino effect of hormone release in the HPA axis. Without sufficient CRH, the pituitary gland doesn't receive the signal to release ACH. Now, remember that ACTH is like a wake-up call to the adrenal glands, nudging them to produce cortisol. Without this alert, the adrenal glands remain in a dormant state, leading to decreased cortisol production. This drop in cortisol levels triggers a range of symptoms, including fatigue, low blood pressure, and weight loss, much like what we see in primary and secondary adrenal insufficiency. However, an important distinction lies in the fact that in tertiary adrenal insufficiency, both the pituitary and adrenal glands are structurally intact and capable of responding to external stimulation. It's the hypothalamus that's not playing its part in this hormonal symphony, thus disrupting the harmony of the HPA axis. To sum it up, tertiary adrenal insufficiency is a condition where the hypothalamus fails to kickstart the stress response, leading to a domino effect of hormonal disruptions along the HPA axis. In tertiary adrenal insufficiency, impaired CRH production leads to decreased stimulation of ACTH release, ultimately resulting in decreased cortisol synthesis by the adrenal glands. To summarize, adrenal insufficiency can occur in three forms: primary, secondary, and tertiary, each linked to a different part of the HPA axis. This complex neuroendocrine system, which includes the hypothalamus, pituitary gland, and adrenal glands, plays a critical role in our body's response to stress and maintenance of homeostasis. In our discussion, we delved into primary adrenal insufficiency, known as Addison's disease, which arises from dysfunction of the adrenal glands themselves. The result is a decreased production of cortisol, our body's primary stress hormone, leading to symptoms such as fatigue, weight loss, and low blood pressure. Interestingly, this insufficiency triggers the pituitary gland to secrete more ACTH in an attempt to stimulate the malfunctioning adrenal glands. Next, we explored secondary adrenal insufficiency, which is caused by a dysfunction of the pituitary gland, resulting in decreased ACTH production. Here, the adrenal glands are structurally intact and capable of responding to ACTH stimulation, but the reduced ACTH levels lead to decreased cortisol production. Lastly, we looked at tertiary adrenal insufficiency, which occurs due to a dysfunction of the hypothalamus. This leads to diminished CRH production, causing a subsequent reduction in ACTH secretion from the pituitary gland, and ultimately, decreased cortisol synthesis by the adrenal glands. Each of these forms of adrenal insufficiency presents its unique challenges and impacts on the body's ability to respond to stress and maintain balance. It's important to note that though different parts of the HPA axis are affected in each case, the common thread is the reduced production of cortisol, a hormone vital for our body's functioning. In the follow-up video, we will review testing and treatment options for adrenal insufficiency. Until then, remember, understanding our body's complex systems is the first step towards better health.